Hello students, welcome to the assignment for simultaneous linear inequalities. So let's begin. So here we have the first question, solve the inequality and illustrate the solutions on the number line. So what we're going to do, right, since it's simultaneous inequality, we're going to break them out into two separate parts and solve them separately. So the first portion here, we have negative 4, which is less than or equals to 2x. So that means negative 2 is less than or equals to x. We could also say x is greater or equals to negative 2. They meant the same thing. Now on the other side, we have 2x is less than or equals to 3x minus 2. So that will give us x is less than or equals to 2. That means x is greater or equals to 2. There we go. Very quickly, right? So how do we illustrate this on the number line? So on the number line, right, we have, let's see, this is x. So with the values of negative 2 here, and then we have 2 here. So what happened? X is greater or equals to negative 2. So we draw a line this way. And greater equals to 2 this way. So the portion that we want, that's highlighted in green, is over here, right? That means therefore the final solution, x is greater or equals to 2. Yep. Right. Moving on. Next one. Solve the inequality and illustrate the solution on a number line. So same technique. Let's go. So we have 3x is minus 3 is less than x minus 9. 2x is less than negative 6. X is less than negative 3. On the other side, we have x minus 9 is less than 2x. That means negative 9 is less than x. So x is greater than negative 9. So illustrate this on the number line. X, we have negative 9 over here, negative 3 over here, greater, less than. So the portion we want is over here. Therefore, right, pull it back. This is the region that we want. Therefore, x is going to be in between negative 9 and negative 3. Okay, moving on. Next one, solve the inequality and again illustrate this. So we're going to start with 3. D minus 5 is less than D plus 1. So 2D is less than 6. D is less than 3. On the other side, D plus 1 is less than or equals to 2D plus 1. So that means D over here, this will be 0. So D is greater or equals to 0. Okay, so put it on number line. It's a D number line. We have 0, we have 3, is less than 3, greater or equals to D. So the region we want, right over here. Therefore, our D is going to be in between 0, or it could be equals, and strictly less than 3. Moving on, next one, solve the inequality and illustrate the solution on the number line. So 2, 1 minus C is greater than C minus 1. So 2 minus 2C greater than C minus 1. That will give us 3C on the right here and 3 here. So C is less than 1. Come on, Apple Pencil. My Apple Pencil stopped working for a while. There we go. Okay, on the other side, we have C minus 1 is greater or equals to C minus 2 over 7. 7C minus 7 greater or equals to C minus 2. 6C is greater or equals to 5. So C is greater or equals to 5 over 6. Putting it on the number line, is C. We have 5 over 6. We have 1. So this way and this way. It's the region we want. Therefore, my C is in between 5 over 6 can be equals and 1. All right. Very quickly, solve the inequality and illustrate the solution on number line. For in this case, we are dealing with the variable D again. So D minus 5 less than 2D over 5. 5D minus 25 is less than 2D. So 3D is less than 25. D is less than 8 and 1/3. On this side, 2D over 5 is less than or equals to D over 2 plus 1/5. So if I multiply by 10 throughout, 4D equals to, that will be 5D plus 2, right? Let me just double check, times 10, times 10, and times 10. Right, that's about right. Okay, so that means D, come on, Apple Pencil, -2, D is greater than -2. Put it on number line, on D number line. This time round we are dealing with -2 and 8 and 1/3. Go this way, go this way. The region we want is over here. Therefore, D is going to be in between -2, which could be equals, and 8 and 1/3. There, nicely done. Okay, now, dear C, Vani wants to give 12 good friends a treat on her birthday. Her friend can either have a cup of bubble tea or an ice cream cone. A cup of bubble tea costs $3.20. Ice cream cone costs $2.40. Vani intends to spend no more than $30 on a treat. Will she be able to do so? If more of her friend wants to have bubble tea than ice cream cone. So what we can do is we can define some variable. Let X be the number of friends who wants bubble tea, right? Bubble tea. Okay, that means the number of friends who wants the ice cream cone will be 12 minus X. Makes sense, right? So based on this, what's the information we have? We have 3.2X plus, right? Okay, I think my Apple Pencil battery is running low. That could be a reason, right? Plus 12 minus X times 2.4. And this has to be less than or equals to 30. Okay, so let's work this out. So we have 3.2X plus 12 times 2.4. That's my calculator. I need calculator for this. Calculator, clear. 12 times 2.4 gives me 28.8. So 28.8 minus 2.4x is less than or equals to 30. So 3.2 minus 2.4. Wait, let me clear this. That's my calculator. 3.2 minus 2.4. 0.8. So 0.8x is less than or equals to 30 minus 28.8. 30 minus 28.8. That give me 1.2. So x is less than or equals to 1.2 divided by 0.8 is 1.5. Right? So yeah. So what happened is, will she be able to do so if more of her friends wants to have bubble tea than ice cream cone? Well, the thing is, no, right? Quite obviously not, because that means that in order for this sentence over here to be valid, okay, X, which is the number of people who wants bubble tea, is actually more than 6, which is half of the 12 friends, right? So no, the answer is no. Okay, in order for let's see, Vanny, that's the name, right? Vanny to do so, X has to be greater than 6. Okay, so yeah, that's how we can answer the solution. Hope you have been successful. Have a nice day.